When we run your test, if this doesn't pass, we stop. You say it does not approximate a normal curve. There's nothing else you can do to it. On this guy, today, we'll see that we go on. This actually becomes your mean, and then we do it one more time, multiply it by the NPQ. This becomes your variance, and then we take the standard deviation of this guy. Only if we pass the test. If it does not pass the test, it does not approximate a normal curve. So there's nothing else you can do with it as far as this course is concerned. Maybe in statistics too, or something, you learned how to deal with curves that are skewed, but not in this course. Now, these are key. Your correction for continuity is key. Remember, lay out where your numbers are. If the number is greater than 109, can I start with 109? No, I have to start with 110, 111, blah, blah, blah. This is my lower end. Drop the lower end 0.5. I can't really raise this lower end 0.5 because I'm in between these two numbers now. Drop this guy 0.5. Then keep the same statement. And once you use the 0.5s, you don't have to use the equal signs. Because what happens is you'll never hit a 109.5. You'll never hit a 0.5 because it's a discrete value. But what it will do is correct this for continuity. It will make your curve a continuous curve. If x is greater than or equal to 109, can I use 109? Yes. So I can use 109, 110, blah, blah, blah. This is my lower end. Drop this guy 0.5. And that came to this one over here. Wait, say that again? Oh, no, wait. Sorry. Oh, this is D. I didn't. I put it next to each other. Sorry. I thought I left them there. Sorry. It's that one. X is less than or equal to 109. It started down here somewhere. Then I went 107, 108. Can I use 109? If it's equal to 109? Yes. My upper end increased by 5. And your last one. You're less than 109. You're down here somewhere. 107, 108. Can I use 109? No. Nope. You take 108 and you add your 0.5. Your lower end drops, your upper end raises. All you're doing is expanding that bar. Yes?
So you don't have to use the equal to sign on any of them?
No.
You can write them with the 0.5?
You know, it's not wrong if you use the equal to sign, because you'll never hit that number because your discrete values are always whole numbers. So it's not wrong. It's just we don't need to. Some books leave them as the original, and in the old book of theirs, when they gave a rule, they didn't, but sometimes in their problem, they did. So it doesn't really matter that you leave it there because you never hit it. So that's why we usually just get rid of it. The second part, it asks you to write this out in words. It asks you to write it in words. And then to correct it for continuity. Usually it gives it to you the other way around. It usually gives you the words and asks you to write the statement. So I found this kind of unique. The old book didn't do it this way. The old book gave you the words and had you match it up and then correct it. So it was a nice way for you to translate it. So the first one, x is less than 25. You could write it just like that. X is less than 25. X is fewer than 25. It just can't be at most, because at most would put it equal to. So read it the way you say it, less than. Now, I write it like this. I start down here. I get to 23. I get to 24. Can I use 25? No. I raise this, 0.5. The probability that x is greater than or equal to 10. You could have even written it like this. Greater than or equal to. At least 110. That means you include the 110. So I'm at 110. I'm at 111. 112. Lower end. Drop it down. The equal sign I didn't do with you. The equal sign says, here's your number 33 all by itself. Here's your number 34. Here's your number 32. They're discrete values. They have no bar. How can I find an area under the curve when I have nothing to measure? I'm looking for the area under the curve related to this. If it's just a point, I have no area under my curve. So we extend this bar halfway, halfway. So now that's the area under my curve I'm going to find. So I take this and I make it 32.5 and 34.5, and I put my x in the middle. Oh, sorry, 33.5. So 33 falls between 32.5. Yes. Yes. So when we do this in a problem in a few minutes, you'll see that we use this with your in-betweens. X is more than, x is greater than, however you said this. Can I start with 65? Nope, I got to start with 66. Keep on going up. My lower end, I drop it 0.5. Are you guys comfortable with this part? This is important. Because the next step is we're going to do our regular z-score formulas. But we have to do this part first. The probability of getting at most is less than or equal to. Could you write less than or equal to? Absolutely. You come all the way up here. We use 149. Can we use 150? Yep. I raise that 0.5. And the in-between, here's your numbers. Now, it's not including, here's the difference. It's not including 55. It's not including 60. So I take this one and bring it down. I take this one and bring it up. That's different than when I do this with the equal sign, because then I go from 55 to 60, and I have to go 54.5, 60.5. It's that equal sign that you really have to watch. When can I use that number? Good? All right, now we're going to see, why do we go through all of this? When do we use this? So let's apply this to what we know. The rest of this is going to work exactly the same. So let's sneak down to here. I'm going to have to shrink this down a little bit here. It's too little. Way too little. Okay. Alright, the rest of the time, we're going to approximate your binomial probabilities. So, we did this. We identified NP and Q. We tested. If we test and everything is good, we can proceed. Now notice, here's your z-score formula. You need the population mean. You need the population standard deviation. But in a problem that says the probability of success is 0.5, the probability of failure is 0.5, I have no mean, no standard deviation. So I have to come up with it. These are the two formulas that we're going to use to come up with your mean, your standard deviation. This is probably why we always test this one, because that becomes your mean. N times P, as soon as you calculate it, that's your mean. And the rest is, we do the same thing. If we correct this for continuity, which we've been doing, that's the x value with the correction that we just plug into your z-score. The rest works exactly the same. So we've got a couple of extra items. We're going to test it first to see if it approximates a normal curve. We're going to find your mean, your standard deviation. We're going to correct it for continuity. Then we're going to plug it into your z-score formulas. Okay? So let's take a look at one. You're going to see they do make sense when we do them. Okay, example 3. Let's get you on example 3. So if you turn to page 278, here's example 3. And they took this from the one before. In case you remembered when we talked about this before, we tested this to see if it worked. In a survey of 8 to 18-year-old heavy media users, it said 47% said they got fair or poor grades. Then you randomly selected your 45, and you asked them whether or not they got fair or poor grades. This is what we did before. We tested this in one of the previous examples. We said, here's our P, here's our Q, here's our N. Thank you, Melissa. We tested your N times P, we tested your N times Q. So N times P gave us 21 point something, point 15, thank you. And N times Q is obviously going to work, right? Because the P worked. So we know they work. Now, first thing to do is lay this out, then test. The third thing we're going to do, if the test works, is we're going to find your mean, which we already know, because we did N times P. Then we're going to find your standard deviation. Just take the square root, and watch how nice this is. You already have the N times P, so you put that in, and you times it by Q. It's kind of nice. You already know N times P, and then just times that by Q. And your standard deviation should be 3.35. Does that sound good to you? 3.35. Okay, now we're going to be able to use your Z-score formula. So we're going to sketch. If you want to sketch. Here's your mean, 21.5. Here's your standard deviations. Okay, you're going to add 3.35 all the way up, and I'll just do it like maybe once here. 24.50. See it? Same as we did before, no different. 27.85. You're good with this? Let's drop it down one. Did you go down one faster? Thank you. 18.15?
You're at 17.8.
Times 3.35.
I got 17.8. I was 21.15.
Yeah, that's okay. You're my good go-to girl still. I'll help you out. Thank you, guys. Okay, so now we sketch like we normally do. Next, look at your probability statement. What do they want to know? What is the probability that's fewer than 20? How do I write fewer than 20?
Be
Less than 20. Good. Now, next step, we correct for continuity. Okay, before we can do the Z-score, we have to correct for continuity. So, we're coming up here. I use 18, I use 19. Can I use 20?
20.5.
Nope. You use 19.5. Okay, now I can finally do my Z-score formula. X minus the mean over the standard deviation. This is my X that I use, 19.5. Minus the mean that we found over the standard deviation that we found. Here's my less than 19.5. Is it going to be more than 50 or less than 50? Less than 50, right? So the rest of it's working pretty much the same. So we're going to find your z-score, -0.49, good. And we're going to do the same thing that we always did. We're going to look up in your table. We want it less than, so we want the area to the left. So we look it up in your table, and you find your area, which is 0.3121. That's it. That's a lot. We have a few extra steps in here. We have to test it. We have to find the mean ourselves. Before, we're always given the mean, aren't we? We're always given a survey that has a mean of, standard deviation of, right? We have to find those. Questions? Okay. We have to find those. We have to write our statement out, and we have to correct it for continuity first. Sketch is always helpful. Even if you don't do all the pieces out, do enough so that you see which way it's going. Because once you hit your z-scores, your area is always to the left, but if your area is to the right, you have to subtract from 1. That always stays the same. Can you use your normal CDF after this? Yeah. As soon as you find your mean, you find your standard deviation, your lower limit, whatever it is you're using, and your x value, as long as it's the corrected one. It'll still find you that if you use your normal CDF, but you still have to go through probably the first 6 parts to get there. It's a little bit long to get there. Okay, let's try it. Let's try another one. Let's do the next one. In a survey, and we had this one previously before, of adults in the United States, 34% of them said they've seen a person using a mobile device walk in front of a moving vehicle without looking. So here's our P. P is 34%. Q is what? We randomly selected 100 adults. And we asked them whether or not they've seen a person walk in front of a vehicle while they're using a mobile device. What is the probability that more than 30 responded yes? How do I write that probability statement? Greater than 30. Good. So hold that thought. We have to test first. Now, in the book, normally what happens is, if your test fails, obviously you can't do that problem, so you kind of don't learn anything from doing that problem. So most of the times when we test these, they will work, otherwise we can't do anything to them. So that's why this seems like a lot of these are working, because they're designed to, so that we can do the rest of it. So we say, yep, 34 is good. Greater than or equal to 5. Good. We test this guy, and we really don't have to because this is the bigger one. So 66, that's good. We now know your mean. Otherwise, there's no mean in here. There's no mean to find. There's no table that I'm going to do. I certainly don't want to do my table 100 times, right? I'd have to do my table 100 times and put it in my L1, L2, and find my mean. Here's your shortcut. So we know your mean. Your standard deviation, we take 34 times the Q and take the square root of that. So your standard deviation is about 4.74. Now again, you can sketch this. Give me a minute, guys. We'll finish this up. You can sketch this. Here's your mean, 34. We want more than 30, so let's just go down this way. So somewhere if I take off this will be 33.26. Nope, sorry, 30.26. Nope, 29.26. Right? So if I want this to be more than 30, I'm here. Is my answer is my area going to be greater than 50% or less than 50%? Greater. Because what's going to happen when you look up your area, you are going to be less than 50% because you looked up the left-hand side. Okay, now before we can do this, we have to correct this for continuity. So can I use 30? No. Nope. 31, 32, blah, blah, blah. So x is greater than, drop this guy, 0.5. Good. And here's where we can be comfortable to get to this point. We put our 30.5 minus our mean over our standard deviation. And you find your z-score. And it still has to match your graph. So your z-score is negative 0.74. And it does fall between the 0 and the 1. When I look up negative 0.74, I get 0.2296, and I say, that's certainly not greater than 50%, is it? That tells me, good, subtract from 1. Okay? Alright, tomorrow we're going to finish this section up, and then do a little homework after that. We got to hit the one with the equal yet.